Hello everyone. In this video, we will introduce a class of stochastic processes called Bernoulli Trials. And you will see that when you have Bernoulli Trials, you will need to know one formula to be able to calculate all the related probabilities. Okay? Let me start with one example and show you how this whole story comes together. A die is rolled 3 times. So 3 times you're doing something in 3 steps. That right away tells me that there's a stochastic process there. Yes. And we are interested in finding probability that the number 4 comes up. Okay. So we roll the first time. Either 4 comes up or something else. Let me just write the event if 4 comes up in a row. Okay, so in the first roll, you either get 4 or get something else. Then you roll it again, and this time also you either get 4 or something else. 4 or something else. And then you repeat this for a third time. But the outcomes are the same things, yes? So either you get, or the events that we are studying or interested in study is either 4 comes up or not, 4 comes up or something else comes up, and that's it. Now, what are the numbers I have to put on the tree? Well, there is only on each row we are interested in knowing what is probability of f, which is okay. There's only one possibility out of 6. So this means that I will have 1 over 6 there, 5 over 6 down there. And this will go ahead and we will have the same story for all of these guys. Remember that since rolling a die first time doesn't change the probability of outcomes in the second roll, then I won't need to be worried about the probability at each level. All of them will give me the same probabilities. Now, exactly 2 4s comes up. So it means that you find paths which includes exactly 2 f, not more, not less. So for example, the first path, if you look, it has 3 f's, so that I cannot take in. But the second one, if you look, there is 2 4s and 1 something else. So that is one of the cases we have to consider. For the third one, that's exactly the same, another case. Fourth one is not, because there are 2 numbers other than 4 and only 1 4. And this guy is the last one. The others all have at least 2 numbers other than 4. Okay, so now if you're interested in finding probability of exactly, or 4 comes up exactly twice, this will be sum of the probability of those 3 passes. The first one is 1 over 6, 1 over 6, 5 over 6. 1 over 6, 5 over 6, 1 over 6, and 5 over 6, 1 over 6, and 1 over 6. Very nice. Well, since the events, the experiments are done, they're independent. So you see that for having exactly 2 4s, you always get the same probabilities on all these 3 passes. It's basically 1 over 6 times itself times 5 over 6. And there are 3 of these guys, so it will be 3 times these numbers. Or other way of seeing this is that, okay, so I know that I am interested in choosing 2 of these rows to be 4. So as you see here, okay, so these 2 or those 2 or last 2. But doesn't matter what are the orders. We can count how many ways we can choose 2 of these places to be 4. 3 choose 2 is what we have. And then for the probability of each one of these guys being 4 is 1/6. You multiply that. The rest, which gives us something other than 4, there are only 1 left for the rest. Okay, this is the formula that we have to learn for general cases. But before I give you the general formula, let me define what is a Bernoulli trial. A stochastic process is called a Bernoulli trial if one of these not one of these things are the properties of Bernoulli trials. First of all, we repeat an experiment n times. There's an experiment, we repeat it. But there's an important thing here, that the experiments are independent. Meaning that the result of the first time that we do the experiment doesn't change the probabilities of the second one and so on. Okay. And the third thing is that there are there are 2 outcomes in the experiment. The experiment that we try each time. While one we call it success, the other one we call it failure. Since the experiments are independent, so it means that the probability of getting success will always stay the same. And we denote it by P. On the other hand, probability of failure, which we denoted by Q, is the complement of probability of success, which is 1 minus P. So if your stochastic process has these properties, then you don't need to do the trees or what we did up above. There is a fact, there's a theorem, there's a mathematical knowledge or knowing that if you're interested in finding probability of exactly k successes in a Bernoulli trial with n trials with the above notation P and Q, this is going to be given by this. So first I choose which one of these n trials to be success, and then I multiply that by the probability of the success k times to itself. The rest of the experiments or the rest of the trials must give us failure, and there are k of those guys, n minus k of those guys, that each one gives us the probability q. You multiply those, you get n minus k. So this is the formula that you need to know. You don't need to know to draw the trees as we did for the first example. You just need to know this one, and that will give you the probabilities. So back to our first example. So basically, we are the trials. The experiment is roll a die. The number of trials, which is we denoted by n, is 3. The success is 4 comes up. And the probability of success, which we denoted by P, is 1/6. As a result of that, the probability of the failure, which is denoted by Q, is 1 minus 1/6, which is 5/6. And we were interested in probability of exactly 2 successes, which gave us 3 choose 2 times P to the power 2, then Q to the power the rest. And that's exactly what we found in that example. Okay, so before I finish, let me do one more example. Here, a fair coin is tossed 4 times. So right away, you have to see this. This is a Bernoulli trial because tossing a coin is independent. When you repeat this experiment, the experiments are independent. This is Bernoulli trial because you repeat something n times, 8 times here. And there's our independent, and we have success here is head comes up, and probability of a success, which we denoted by P, is 1/2. Probability of failure is 1 minus 1/2, which is 1/2 as well. What is the probability we are looking for? We are looking for probability of exactly 5 times the head comes up. So we are interested in exactly 5 successes. This will be choose 5 out of 8. 8 choose 5. Then P to the power 5. So I make those ones success. The rest will go for failures. In this case, the tail. And that's the probability that we were interested in finding. Okay. So that is what a Bernoulli trial means, and the boxed formula is what you need to know to be able to evaluate the probabilities related to Bernoulli trials.